Hi everybody, welcome back. We are now in Quartus, and actually here, I'm going to get out of Quartus and just show you. I'm going to go ahead and hit the start menu. I'm going to find Quartus. I want to right click, this is important, run as administrator. I've had some problems with creating new files and things that this wasn't ran as administrator, so I just want to make that clear. Go ahead and run as administrator and hit yes. And now that you are in, we can begin a new project. There are 3 different ways to begin a new project. The easiest way is just to click on the new project wizard here. You can also go File, New, and select New Quartus Prime Project. And you can also go File, New Project Wizard. Any of those 3 will take you to the same place, which is the New Project Wizard. You'll get this introduction. You can choose whether or not to show that again in the future. We're going to ignore it right now and just guide you through it. The first thing it's going to ask you is where you want to save your project, and I highly recommend that you don't save it in the default place. It's going to, by default, save it just in the same area where you installed it. It just gets really confusing later on if you got a bunch of files in there and it's not very organized. So instead, I like to save mine in some subfolders. So I have an ECE 3700 project folder right here. And I've already created a new folder inside there called Verify, which is the name I'm going to give this project. If I hadn't had one, I would just right-click and choose New Folder. There we go. Yep, just choose New Folder. And give it a name that I like. I'm going to go ahead and keep Verify. Okay, I'm going to give the name of the project the same thing that I named the folder. And I'm going to leave this the same, the top level design entity. You could change this if you wanted to, but I don't recommend it. It just is clean to have them both be the same. I'll explain what that means in a minute. For now, I'm going to leave everything else as it is, and I'm going to hit next. Okay, we're going to choose an empty project. We're not doing any templates. And we don't have any files to add or libraries to include. So we're going to go ahead, and it's going to take us to this family device and board settings. Now the first thing you want to do here is take a look at your board here, and you'll see that it has a large square chip in the middle. That's the actual FPGA. Everything else is peripherals and extensions. So when we look on the FPGA chip here, it says Altera Max 10, and then below that has a serial number 10M50DAF, and then something else. Oh, there's the name filter. Okay, so under device, I'm going to type name filter, and I'm going to start typing in the serial number. 10M50. Make this a little bit bigger so I can see what kind of options I'm getting. 10M50DAF. 484 C7G. There it is. So that's the device I want. So I'm going to go ahead and select that one. Ignore board. Yeah, that's what I want. Available devices. I'm going to go ahead and select that one and hit next. So I'm not sure that was very clear, so I'm going to go back and show again. Basically, I'm just going to select Max 10 as the family because it's the Max 10 board. And then over here, I'm going to choose under name filter, and I'm just going to start typing in the serial number that is on the chip. And this is the serial number that you will all have, 10M50DAF4847. You filter that in, and it will come up here, and that is the device that you'll select. All right. Next. Now, under simulation for EDA tools, we'll be using Model Sim. So we're going to select tool name, and we're going to choose Model Sim Altera. It's important that you select Model Sim Altera and not just Model Sim. And we are using Verilog as the format, so you're going to leave this as Verilog HDL. If it doesn't say that by default, that's the one you'll want to select. And then we're going to go in next. And finish. And if everything went well, in a few minutes, you will have a new project. Now there's no files in it, so we can go ahead and create a new Verilog HDL file. Hit OK. And now we can start writing some Verilog. Let's write a very simple, very simple module here that does absolutely nothing. Say module module verify with capital V. And when I selected the top level entity, that means that I have to name my module the same thing as the top level entity. So since I didn't change it, the module has to be named verify. Now, naming modules and what modules are, and Verilog syntax and stuff that we'll get into later, but for now, just know that that's what the top level entity means, and that's why I didn't change it. So, module verify, and then I'm going to go ahead and hit a semicolon here, and I am going to type input wire A, output wire B, assign A equal B, end module. Okay, very simple. All it does is it takes an input A and an output B and assigns A equal to B. Cool. So we're going to go ahead now and hit this. We're going to save it first, sorry. And we will save it as verify.v in the 3700 verify folder. And now that we have that, we're going to go ahead and hit compile. And if we don't get any errors, this process takes a while. There we go, already made a mistake here. Top module port A is not found in the ports list. You are correct. So I actually need to go verify A, comma B, and declare those as ports. And I think we should be good. This is a normal process of Verilog. Unfortunately, the text editor doesn't provide you with a lot of help as far as syntax, and so unless you have the syntax memorized, it's really easy to make simple mistakes like that. Alright, and value cannot be assigned to input A. I thought I didn't do that. Oh, assign B equals A. A is an input, B is an output. So, as you can see, I don't have the Verilog syntax memorized. I make mistakes all the time. So the best thing you can do is practice, read the manual, and ask questions. There we go. So now we're not getting any errors. The whole thing compiles. So we're good to go. Okay. Now with that compiling, I'm going to go over to the pin planner. That is this guy right here. It's the little pen with a, I think that's supposed to be like a pin, like a little pencil with a pin. But you can also just go to Tools and Assignments and go to Pin Planner here, if that's easier. So Assignments Pin Planner is how I usually find it, because I can't remember what the logo looks like. Now this is where we're going to assign the actual pins to the board to say what inputs and outputs go where. You'll see here that it already knows that my module has one input and one output, and it's going to ask me what I want to make my input and what I want to make my output. So I'm just going to select my location here, and we're going to go, I want to say it's oh shoot, I can't ever remember. It doesn't really matter. We'll just pick a couple of random pins. So I'll say pin A7 for input. I'm not even going to really demonstrate what this looks like on the board because it actually doesn't do anything at all. I just want to know that I can flash the board. We will get into what these pins mean and how you can look them up later. Right now I just want to verify that I actually can write something to the board. So we'll go ahead now and choose, just close that. I think that's all we have to do. There's no save here. Okay, and unfortunately this is kind of a frustrating thing, but you have to compile before you can run the pin planner, and then you have to compile after you run the pin planner. You're going to do a lot of compiling. So we'll compile one more time. In general, the pin planner is how we would specify what inputs and outputs on the actual physical board we want to use. So we design our module using Verilog syntax that says we have these inputs and these outputs, and then the pin planner lets us assign what those symbolic inputs and outputs actually are linked to on the physical board. Okay, so we are done with that. We are going to go to the programmer. So we're going to go to Tools, and we're going to launch the programmer. I think there is another icon up here somewhere for that, right there, yep. But I just do it through the Tools menu. Alright, now that we're in here, we're going to click on Hardware Setup. We are going to, under it says No Hardware, we're going to select USB Blaster. You should have that option. So we're going to select USB Blaster here instead of No Hardware. It'll let me. Give my computer a minute to breathe. There it goes. It just was having a hard time for a minute. Alright, so we select USB Blaster as the hardware. You should have that installed because that was the driver that got installed with Verilog. If for some reason with Quartus, if for some reason you don't have that, you'll have to install it. You'll have to run it manually. The best way to do that is to go over to your C drive. You'll find Intel FPGA Lite and your version, and then you'll find under there you'll find Quartus, and then from here it's under drivers and USB Blaster, and you'll have to install it manually. So this is where the driver is, and there's a few steps you have to go through. If for some reason you're not finding it, let me know, and I will walk you through the specific steps on how to install it from these files here. You can also try just running the DP installer, which should be enough. So try that first. If that doesn't work, try that first. If that doesn't work, then I will help you through the other way. Hopefully that's not an issue. We can just go USB Blaster and it's already installed. Okay. We're not going to worry about hardware frequency. The USB Blaster actually is going to take care of all of that for us. I'm going to hit close. And now what we want to do is to click on the Auto Detect button. I can't really make that larger, but that's Auto Detect right there. And now it's found me an output file. And that is the correct output file. It's just, I know because it's the correct name and it's the only one I should have. And we're going to go ahead and hit start. And 100% successful. And you'll notice that my board is no longer blinking. Oh, where are we? Now I don't know what pins I selected or where they are on the board, so I can't test that it worked. And even if I could, it's just one in and the same thing out, so it's basically a buffer, but not even a useful buffer. But anyway, the point is that it is working. So you should be able to do something similar and see that your board is working, that you have everything set up. That's pretty much everything you need to get started with the class. I will have a few other tips and tricks along the way that I'll help you with and share with you guys, but that's pretty much it. Thanks for taking the time.